All right, calc students, here is the third example of finding places where a function is increasing or decreasing or concavity based on calculus. We're going to do this, number 22. Let's clear this out from the last one. And I apologize, I think we might have been not had sound on the last one. So if you have a question, email me or put a comment in there. All right, let's see. We're going to do this one, number 22. This one is kind of algebra and analysis heavy. When you want to find out a place where f is increasing, decreasing, or concavity, you look for the first derivative. Increasing, decreasing is first derivative. F prime of x. This is quotient rule. Low d high, x squared plus 2 times 1, I won't write it, minus high d low over low squared. That's x squared plus 2 squared. I'm going to clean that up a bit and make that x squared plus 2 minus 2x squared all over x squared plus 2 squared. And that becomes negative x squared plus 2, or I'll write it as 2 minus x squared all over x squared plus 2 squared. Whoa, that's the first derivative. When we want to find out where the function is increasing or decreasing, we look to the first derivative. About this part, this bottom part, x squared minus 2 squared, that's always going to be positive. I'm going to write a note that that is always positive. So I really don't even need to analyze that to find out where, if a function is, well, it's never even going to be 0 either. There's no place in our real number system where that's going to be 0. So I just need to focus on the upstairs part here, 2 minus x squared. And to just find out where that is equal to 0, that is where x squared is equal to 2, or x is equal to radical 2 plus or minus. So let's see, I'll make my number line up here that has a negative radical 2 and a radical 2, and just analyze that. You know what, I'm going to do something different this time. How about I make a table instead, because I'll make a table instead of a number line. So from negative infinity to negative radical 2 is one interval. From negative radical 2, let's clean that up, to radical 2 is kind of the middle interval, and then from radical 2 on is the third one. And I'm going to look at my x and then my 2 minus x squared, and then to find out what f prime of x is doing. So that's my table. The square root of 2 is around, like, it's more than 1 but less than 2. It's like 1.41. So when I put in, I'll try like a number like negative 2 from that interval from negative infinity to negative 2. When I put that in for x, I get 2 minus 4. That's going to be a negative value, so I know f is decreasing. I'm going to put f dec from negative infinity to negative radical 2. In between negative radical 2 and 2, I'm just going to use the number 0. 0 should be your friend. That's going to be 2 minus 0, or 2, and that's going to be positive. So we are increasing from negative radical 2 to radical 2 in that interval. From radical 2 on, let's use the number just 2, something, a test point that's easy to analyze. 2 minus 2 squared is 4. That's going to be a negative number because that's like negative 2. And that means we are back to decreasing. So f is decreasing from radical 2 on this function. Okay, might have to do a little bit of space here to find now, wow, second derivative. I said wow because that is the first derivative. So now the second derivative is going to be this. Low d high. So that's low x squared plus 2 squared d high times minus 2x minus high d low. Wow, and the d low is a chain rule. That's going to be 2 times x squared plus 2 to the first power. Then the derivative of the inside is 2x. I'll have to clean that up in a little bit. All over low squared. X squared plus 2 squared squared. Man, all right. It won't be so bad. We've got, oh, you know what? I see something. I see an x squared plus 2. I see that in several places. I'm not going to multiply it out. I'm going to factor it out in the next step. So negative 2x times x squared plus 2 squared minus, let's see, that's going to be 4x times 2 minus x squared times x squared plus 2, all in a bracket, all over x squared plus 2 now to the 4th. Yikes. All right, I'm going to factor out what I can, which I think is a negative 2x and an x squared plus 2. And what's left is x squared plus 2 minus 2 times 2 minus x squared. See what happened there? I had a x squared plus 2 that was common here, here, and then I haven't finished my denominator yet. That is all over x squared plus 2 to the 4th. All right, man, so I'm going to do some slashing here. X squared plus 2 to the 1st over x squared plus 2 to the 4th means I've got a cubed here. And so what's left is, and let's work on this top part. That's x squared plus 2 minus 4 plus 2x squared. That's going to be x squared plus 2 plus, man, I know you might be screaming at me, where did I find x squared plus 2? Should I have a positive in there? No. So I'm multiplying at 2x, and it's going to be is that a x squared plus 2 plus low d high minus high d low over low squared. Man, I know I've got it somewhere. I think I have negative 2x, and then I think I should have x squared, negative x squared plus 6. All right, I'm going to go for it. Over x squared plus 2 to the 3rd power. Oh man, I think I've never done this before. I think I've got something going on there. But I'm going to trust my notes that you'll find it for me. Whoa. This thing here, always positive. That's always positive. So, let's see. I think this is supposed to be a plus eventually. That's going to be a plus 2 2 times 2 minus x squared, which is going to be a minus 2x squared, and that's going to be a plus 4. So I think that's where I get the x squared plus 6. I'm sorry, school is ending. I got to keep going. So now we're at the second derivative. This is f double prime of x. This is f double prime of x. And so we want to analyze where that might be equal to 0. Since the denominator is always positive, we really only have to focus on this top part. And the top part is equal to 0 when either negative 2x is equal to 0, in which case that's x is equal to 0, or when negative x squared plus 6 is equal to 0. And that means where 6 is equal to x squared. And that means x is equal to plus or minus radical 6. Plus or minus radical 6. That tells me now that my inflection points or concavity could be at negative radical 6, 0, or radical 6. Now we look at the second derivative, which I'm going to highlight here. That is, and I don't even really need to worry about the bottom part, so I just need to pick numbers that are to the left of negative 6, of radical 6, and I'll pick, like, say, the number negative 3. I'll try negative 3. That means negative 2 times negative 3 is going to be positive, and then I'm going to square a negative 3, that's a 9, but then a negative 9 plus 6, that's negative. I think I'm looking at a concave down action right here. From negative radical 6 to 0, let's try like negative 1. That means I'm going to have a positive first aspect of the negative 2 times negative 1, and then I'm going to also have a positive for the second term, or the second grouping symbol, so I am concave up. From 0 to radical 6 is a little bit more than 2, so try 1. And that means negative 2 times 1 is that's negative, and then a negative 1 plus 6, that's positive. I am negative there. I am concave down. Past radical 6, let's try like the number 3. That's going to be negative, and still a negative. I'm looking at a net positive. We are concave up. All right, so that means before I even graph this thing, it looks like inflection points happen where concavity changes. So it's going to be at negative radical 6, 0, and radical 6, because those are all places where concavity has changed. All right, let's take a look at what that looks like. So this is x over x plus x over x squared plus 2. Resembles something like this. I believe it is something like that. We are decreasing from negative infinity till negative radical 2, somewhere right there. Then we are increasing from negative radical 2 up to radical 2. There, I'll change it to that part. And then we're decreasing again from radical 2 on. So that places my radical 2 something like there. When it came to concavity, we are concave down from negative infinity to negative 6. So you know what? I think I might have to redraw this one, because I think we are concave down, concave up, concave down, concave up at radical 6. So something like here is where concavity changes from down like a frown to up like a cup. And then at 0, we are down like a frown again until we reach somewhere right here like radical 6, where we are up like a cup. Wow, that one is tough. Thank you so much for enduring that one. And send me comments if you can find out what I did, my analysis on that second derivative, so that I can clean this up in the future.